So absorption is what we would say happens to a signal when it doesn't bounce off, which would be reflection, or moving around an object, as we'll see here with some of the other terms here that you'll see. But instead, it doesn't bounce off, it doesn't move around, but it cannot move. If it cannot move through the object, then we would say we had 100% absorption. So imagine, if you would, that if I had a wall and even put a door, wood door, metal door, doesn't matter. I'm hoping I've got some perspective here going on with this office building. So that'd be the side wall, and then of course we'd have the rest of the floor, but I don't think I'm going to try to make a 3D object. But the idea is if I have this antenna that's going to start radiating, in this particular case, if it cannot get through the wall, then we would say 100% absorption. But what we might say is that when we look at that signal, it may be better to make this look like a sine wave. So we have a high amplitude signal, and when it hits that wall, when it comes out, it has a lower amplitude, and that's because the wall managed to take some of the power out of the amplitude, and so we still have the signal going through, but we would say that some of that signal had been absorbed. As an example, with a 2.4 gigahertz signal, if it goes through a brick wall, we'd be at about 1/16 of the original power. The same would be with a brick or drywall, right? Just regular, not a big solid brick. We would say we would lose half of the original power. And so that's just an example, as I tried to draw there, with the change in the amplitude of that signal as it moves through an object.